Good morning. So I really appreciate you guys for coming early morning talks. So it's really difficult to attend early morning talks. So I appreciate that. My name is Arun Mane. I'm founder and director of INFOSEC Labs LLP. It's an Indian-based company. And we are into hardware, IoT, ICS, and vehicle. We do a lot of research in those sectors. And I'm also the speaker and trainer for a lot of conferences, including DefCamp. So what exactly the ICS? ICS is nothing but industrial control systems. Like it consists of a lot of components, like PLCs, then HMIs, then RTU, and the SCADA systems. So whole things is called as the industrial control systems. So industrial control system is like so critical for every nations. So let's understand what exactly the SCADA, HMI, and PLC and RTU in very short, actually. So SCADA is nothing but the supervisory control and data acquisition. It's a type of the industrial control. It's a part of this industrial control systems. But if you compare with IT, it's nothing but like if you compare with the SIEM tool, right? So it takes logs from the other devices, network devices, OS, and everything, and put it on the graphical user interface, rather graphically, and they understand what kind of alerts is there. The same thing over here is like it represents the process nothing but operation technology. In that case, we call it as a OT. So here, HMI is like human-machine interface. It's specifically dedicated to the PLC devices, RTU devices. So this comes with a graphical user interface. So what we are trying to say, like, it comes in two flavors. It's a hardware-based, the HMI, and the software-based HMI. So software-based, nothing but our classical things called like the web applications, any front end which represents the graphical thing of any very small operation is called as HMI. And if I talk about the hardware, it's nothing but it's a display, right? So display comes with a touch screen and everything like buttons and everything. So it requires human interaction. So this is it's called as nothing but HMI in hardware. So RTU is nothing but remote terminal unit. So it's the same like PLC, but it's not advanced than PLC. But there is a very small difference between the PLC and the RTU. Is a telematic units. So it's not a telematic, it's a telemetry units. So in that case, so they use modems connected with any hardware device. This is called as RTU. So this is the main difference between the PLC and the RTU. So PLC is programmable logical controller that connects with the sensors, and this connects with the sensor which comes in the level 0, level 1. So on the level 1 is always be the PLCs. So it's a programmable language, and if you see over here, it's like IC 61131-3 programming language. There are different kind of programming language nowadays. Every PLC supports. So this is same like RTU, but So the key difference is really different. So like key difference is the telematic, or rather you can say telemetry device. So this is how this first one is nothing but the SCADA, and this is how the HMI, which is in hardware fashion. So this is nothing but hardware, but you can see this very small, the display is nothing but HMI as well, and this is kind of the PLC as well. So PLC and the RTU, and behind the RTU, you'll see always the modem, which is connected with the 3G, 4G, or 2G connection. So what exactly the typical architecture of the industrial control systems? So whenever we talk about the ICS network, it starts with the sensors. Like sensor over here, sensors and actuators let's take an example of water dam, right? So water dam has some kind of sensor which responsible to close the door or open the doors. These sensors or actuators over here, and that sensor goes to the RTO or the PLC, and that goes to the communication network, and it connects to the master devices. So if you go in a little bit depth, it's like a field instrument at the end of the network. We call it as the sensors. Then send it to the PLC, rather RTU, and over the communication network, maybe a Wi-Fi, maybe not Wi-Fi exactly. It's maybe RF, or maybe you can say the wired network, right? So Ethernet communication, whatever it is, and that communicate with the SCADA machines. So this is how the field engineers or rather any operation technology works in the industrial control systems. So what are the communication protocols? If I talk about this communication between the PLCs and the SCADA machines and between the PLC to PLC, there should be some protocol, right? So protocol would be like depend on the what are those criteria. Like if you talk about the process-oriented protocol, rather you can say the metering protocol, you will see the Modbus serial and TCP protocols. So Modbus serial for use for process and metering, meter reading, those kind of stuff, those kind of communication you can see on the Modbus protocol. DNP3, whenever we talk about the DNP3 or IEC 61850-4, so these are protocols used in the electrical utility. So these electrical utility use those kind of protocols. So Profibus, again, it's the same like a Modbus, but the packet structures and the flow of communication is differ from the Modbus, but is for the process communication. BACnet, if you talk about the BACnet is mainly used for the building automation. So if you see the lifts, or rather you can say the skyscraper buildings are there. So these building automation is done by the BACnet protocol. BACnet is nothing but proprietary protocol from the Siemens, but it's again vulnerable. So why we are understanding the security? Because if we talk about the industrial control system, we are nothing but talk about the nations, right? The nation's wealth. It's a backbone of every nations. So it's maybe a nuclear plant, it may be a electrical utility, because these are connected with every infrastructure, like banking and the health and everything, because we require the electricity. So electricity flows everywhere, in every sectors. So because of this being a very niche area, being a very important area in the nation-wise, so there are a lot of incidents happens, like state-sponsored attacks you can see in this field actually. State-sponsored attacks with the well-known malwares like Tuxnet, Havocs, Black Energy, Duca, and there are n number of ransomwares comes in the industrial control systems nowadays. So when it comes to the industrial control system, specifically it's attacks on the machines, like Windows machines. Usually the field engineer use their softwares like to program the SCADA application. If any change comes in the pictures, to program the PLCs, rather. We can take an example of solar energy or other wind energy. Those peoples are same machines they use for configuring some gateways, Modbus gateways like Advantech, you can take any Modbus gateway example, and same machine used for monitoring those the SCADA machines as well. So this is what the implications, like if something happened with the software, rather someone inject some malwares, rather anyhow it in a different way through a different attack vector, malware comes to the picture. So it will encrypt. If it is ransomware, it will encrypt the entire machine, or rather if it is any Tuxnet or other any Black Energy kind of malware, so we can attack on process communications part. So it's 2015 2015 statistics, but if you compare with 2016, 17, 18, 19, it's a huge attack. You can see in Ukraine and other part of world. So these are the things where, if you talk about the 2010 and 2011, you'll see those information related to the Stuxnet, which affected in 2011 and 2012, and after that it comes to the 2014 as well. So you'll see the n number of and the different type of families of malwares introduced in these years. So what exactly the challenges we are facing? So challenges are like it's a lack of knowledge. So people don't know how the industry control systems works. People know about the IT, right? IT routers and everything. The people come to know what exactly these things. But when it comes to the actuator, when it comes to the instrumentation or other instrument engineering, so that becomes very niche area, right? So it requires industrial experience as well. So if you want to make a career, or other, if you want to learn those kind of niche area, you have to be prepared, or other you have to have knowledge about the industrial control systems and the communication part. So if I talk about being a researcher, being the hardware hacker in that case, so or other pen tester, so you should come up with your lab setup, right? So lab setup, that is again costliest. So if you're going for the industrial control, you have to purchase PLCs, then setup, then you have to learn all the communication. Then after that, once you get ready with the entire setup, then you can start hunting those vulnerability, or other you can say you can do some sort of the research. So again, due to hardware includes in the setups, its cost includes as well. So it's costliest experiment as well. So there are some the simulations available in the market with respect to the protocol. So like a Modbus, like a DNP3 protocols, they have simulations. So you can connect with those simulation, and it works on the IP address, and you can start the research on at least the protocol level. But here in this talk, we are talking about the protocol itself and the hardware itself. Why a lot of people not considering the hardware attack on particular, the industrial control system devices like PLCs or third-party vendors like the Modbus gateways they use. They're so vulnerable with respect to the hardware device. So if you talk about the simulation, there are different kind of simulation available. That Modbus PAL is another kind of simulation. Conport is another kind of honeypot actually. So if you guys in the threat intelligence, you can use Conport, you can modify, and you can. It looks like any kind of the interface of the any PLCs like Siemens 600, Siemens 200. 1200 or 1500, you can make a lot of changes in the Conport, and you can upload it on the particular things. Gasport is nothing but AST protocol. It's like the above the tank protocol is related to the pumps. SCADA BR is another free open source. The SCADA BR is the free open source application where you can connect with those devices with the SCADA BR, and you can do a ton of things. So you can use Modbus PI if you're very interested in the Modbus communication. There are different types of the libraries available. So Modbus.py is the good library. You can create those libraries or scripts, so you can connect with the Modbus communication, or you can fuzz the entire communication. Even the DNP3, Open DNP3 is another kind of library, so you can use it and you can do some sort of fuzzing as well. So there are different kind of tools available. Like Nmap is the, if you're going with an Nmap, so you make sure that you have something, the script related to Modbus. So if you do some sort of blind port scanning, so it will create a havoc in the system itself. So at the end, what we are doing, so we are interacting with the hardware, and hardware doesn't know what exactly the protocol, what exactly the data. So there would be possibility you can create the DOS attack in the entire communications. PLC scan is one of the good tools. There are Modbus libraries available for the scanning SCADA machines, for the Modbus as well. The Wireshark is one of the good things where you can intercept the communication, you can understand what kind of communication is going on, and you can dissect the entire protocol. And based on the protocol information, you can do some sort of replay attack, relay attack, and ton of things after getting the knowledge of the protocol. MBT gates, it's again the tool where we can show you the demo as well, video demo, where how we can use that MBT gate and we can interact directly to the PLCs. Gasport commands, it's nothing but the AST commands, which actually the device, the embedded device situated on the pumps, where it takes the measurements of all the diesel and the petrol and everything, and it shows the statistics. And these communications are still, the plain text. So you can use those commands and you can interact and you can change some statistics on the microcontroller itself, and it shows different values to the engineers. So now we are talking about the Modbus. Modbus is nothing but the protocol which is originally designed and introduced by Modicon. Now it's a Schneider, so it's a royalty-free protocol, and it's a most standard protocol in the industrial control systems. Like if I compare like this, I cannot say the 60%, but at least 40 to 50% you can see this Modbus protocol being used in the industrial control systems. So this is the huge and the standard protocol followed in the industries. And if you see this Modbus communication, so it's a master and slave based protocol actually. So whether it is a serial or whether it is you can say the TCP/IP protocol. So if you talk about the serial, there are two types of serial like RS-232 and RS-485. It's depending on the voltage, how much voltage you are using for which serial communications. So as I said, it's a master-slave protocol, and the master pulls the information from the slaves, that things, and every master can communicate the 247 slaves. That means every master can have 247 slaves in the network itself, and this is like very clear text protocol. There is no at all authentication. If you snip the entire communication and you can see it on the Wireshark, you will come to know how it's vulnerable actually. So if you dissect the entire protocol, so there are some key things we need to take care of it here, like as a pen tester, as a hackers, or any background or other developer. So key thing is a function code actually. So if you know the function code exactly, so you can communicate with the register values, coil values. So if I talk about the coil, that means I'm talking about the digital values, that is 0 and 1. Like take example of the water dam that shut down the entire door or open the entire door. When it comes on 0 and 1, like 1 is like shut, it will close the entire door, and 0 is for opening the door. So when that function comes into the picture, we call it as a coil. When it comes to the temperatures like, let's take an example of nuclear plant, right? So in that nuclear plant, if fusion reaction comes into the picture, so temperature goes in a different level, right? From the threshold, like a 35 degree to 80 degree. So 80 degree would be the threshold value. When it goes to threshold value, so it gives alarm, right? So in that case, you can see the register values comes to in the picture. When it comes to, this information is required for the developers, rather you can say, it's for the engineer. So SCADA programmer, they do those kind of stuff actually. And the function code is like, if function code 1 is used, you can see the read coils. And for a single coil, you can use function 5, and holding register function 3, and write single register 6, and ton of things like read and write multiple register, you can use the 23. So there are n number of the function codes available when it comes to the picture actually. So if you buy any PLC device which supports Modbus protocol, so they come up with the data sheet where they mention everything about what kind of function codes that particular PLC supports. So it's now it's a demo time. So. So here we have the PLC and we have the panel, hardware panel, where some indicators are here, some actuators like on and off, right? So here is like, here I'm turning on, that is green signal, rather alarm you can say. And when I turn on that particular switch, so it's activate this thing. So when tweak that particular, yes. So as I said, so if I use MBT gate, so I will use function the function which is I can read the coil values. So turning on and off, it's nothing but 0 and 1 for the indicator. So here I'm using R1 is a function with respect to the MBT gate, and -0, -A0 is I'm starting from the offset from 0 address. And this is the IP address. So you can see the one value for 0000 address. And this is why the green signal is on, the indicator. So if I do off, and if I again read the same value, so you'll see on the second line, it's a 1, right? So I toggle that from left to right. So you can see the on memory address, there something is changed. So here, again, I switched on the, so now the PLC has the input and output. So output would be our indicators, input will be the actuators. So I know the memory address for the output. So it start from the 256. So when I do any things like switch on, switch off, so it will shows one value over here for 256. So if I do off, so you will see here is a 00 values. So that means there are for input and output, they allocated some memory addresses in the PLC itself. So what happened if our malware is in the industrial control systems, and our malware is talking on the Modbus protocol, and our job the attacker's job is to gives false positive alarms. Like in that case, it should be a green, but it's supposed to be green, but it's showing a red alarm, right? So in that case, what I will do, I will change that value particular to the output, and it will shows red. So let's do that actually. So we are writing the coil values, that particular that particular address, and that is our 257 for the red value, or rather red alarm, and 256 for the green thing. So Okay. So if I do the write command for 257, and if you see this thing is get changed to red thing. So the thing is, the engineers, or rather you can say field engineer, get confused what exactly is happening in the process environment. So there are different ways to mitigate those problems while there are different ways to mitigate those problems. We can use different kind of gateways, unidirectional gateways, which can encrypt the communication from one end to other end. But it's really difficult to those solution implement in existing infrastructures because of it's a cost-effective, or other you can say the hardware dependency, or other you can say the critical process. It's really difficult to change those devices in that case. So let's come to the hardware part. So if you open the hardware, let's say we saw the PLC device, right? So if you open the PLC device, you will see some sort of the lot of PCB board, printed circuit boards, and you try to find out some you can say the test pads. So test pad, nothing but the UART, JTAG, anything. So when you are hunting the UART port, is there a lot of possibilities you will find 2 or 3 UART port or single UART port. So in that case, in some devices, we found 2 UART port. One is for the debugging purpose, one is for the monitoring purpose. Like monitoring whatever you do, some changes at the end of the hardware, you will see some logs, right? That is called as a monitoring purpose. And debugging is like you are directly interacting with the firmware, or other any changes you can do on the embedded systems. That thing is for a debugging purpose. So in that case, we need to find out first the RX and TX and ground, which can connect with your the UART device, and you can easily interact with the particular target device. And in this way, there are different ways to do that. You can do with manually with the help of digital multimeter. There are different ways you can do with the JTAGulator. So JTAGulator is nothing but the automated thing, like for port scanning, we use Nmap. So for hardware interface, for understanding the UART and JTAG, they use JTAGulator to find out the particular UART and the JTAG. So as I said, we found 2 UARTs in particular devices. One is for debugging purpose, one is for the monitoring purpose. But the fact was different. So when we found that particular the UART, so when we connect, we found the root access on the particular devices without any credentials. So one port is asking for the credential, one UART is asking for the credential, one UART is asking for it's never asked for the credentials. That's what it believes. So in that case, we found something. This device is nothing but the RTU. So nowadays RTU comes with an extra RAM actually, and it has a minimalistic Linux server on the particular machine because it supports the web application as well. So when it comes to the web application, there are a lot of possibilities. They come up with a Linux machine. So in that case, we found the baud rate 115200, and then we fall into the root shell. And we check that what exactly it is the ls command is working. So from the ls command, we come to know that this is the root folders, and that some files are there. So if you go to etc and passwd, you will find the credentials as well. So this is how the particular hardware testing done. So here you can say that there is a different way to extract those things. What if the UART is disabled, JTAG is disabled? So what other way you can find out? So there are different kind of chipsets on the PCB board, like the NAND flash, or rather you can say SPI. These are the double EEPROM, SPI and I2C. So there are a lot of possibilities. Some engineers store some firmware in the SPI double EEPROM or the I2C double EEPROM, or rather they store some data like credentials and everything, AS key in the particular thing. So this is how we done with, this is the double EEPROM programmer, that SPI and I2C. We have the clip, the SOIC8 clip. SOIC8 testing clip is like, it has 8 legs on the SOIC chipset, that is double EEPROM. And we found that this is the SPI, right? So that's why we use 3041A. It's a Chinese device which comes in very $4, right? So if you go for a commercial thing, it's cost around $300 to $400, but it's really cost effective. That can connect with the double EEPROM, and from double EEPROM, you can extract the entire data. Once you extract the data, we'll come to know that this communication, then after that, we found some credential. So whatever you changes on the web application or other root level, you'll see over here. So the initial was the root admin. So we see some changes. So we found those credentials as well. So whatever you do, update the web application or other any firmware changes, it stores in the SPI. So this is how architecture, and this device is the Modbus gateway that converts the Modbus serial to Modbus TCP communication. And this is how you can find the data from the, once we extract the data from the chipset, and you'll come to know those credentials as well. The conclusion is it's like, it's need to be secure from the hardware perspective as well, because if I talk about the Mirai is again the botnet, and they have n number of different families of the Mirai botnets, which can communicate on the default credentials, and they can flash the entire firmware, and they can do some sort of nasty things. Again, should be a security awareness, and there should be a bug bounty program for the industrial control systems protocols. And do you have any questions?
Yeah, let's take a round of questions. My colleagues will help you by giving the mics out in the audience.
What's your opinion on SCADA securing, like firewall versus unidirectional gateway?
So it's depend on the first. It depend on the architecture. So if target state architectures with respect to current state architecture, if you're modifying those architecture with respect to the security, so it's depend on the what kind of devices you have in the level 0, level 1, and level 3. So I would recommend if it is a 3.5 level, that is DMZ, you can use NGF and next generation firewall. And if comes to the level 2 and level 1, you should use unidirectional gateways actually. So there are different kind of gateways, like if you talk about the UPX, OPC UA, you can use that kind of gateways as well, that communicates with other different protocols. So it's differ from the protocol to protocol. If your industrial control systems or other entire communication works with a different type of protocols, like including IEC 61850 and the Modbus, so in that case, you have to check which device can fit, but unidirectional gateway is the best option.
Okay, and did you work with Flip?
Sorry?
Flip?
Flip, I'm not getting actually.
Okay.
So we'll discuss, yeah.
Let's take a question from the other end of the room.
Here.
Yeah.
Thanks for your presentation. I have a question. What's the basic toolkit you recommend to get if you want to start hacking?
So if you want to, Yeah, so if you want to start with hardware hacking, so first you need to find out which devices is for use for the hardware hacking. That is must thing. Then you can buy Chinese devices. So these Chinese devices very low cost effective and still vulnerable. So it's a best practice. You can do the hardware hacking on the Chinese devices apart from the US or the European devices. Now US and European devices so secure. From I think so, as per my knowledge, 2015. From 2015, they are securing a lot of devices. So if you buy any device, Chinese device from the AliExpress, there a lot of chance you can get the vulnerabilities in the device itself. So I would recommend you any web camera which comes in $10 to $20 camera. So there would be possibility at least you can get the UART access on the web camera. But for tools, definitely you can talk after we can discuss after the talk as well. So what kind of tools you require for those kind of hardware testing, I will give that list.
Okay, I'll feed you after.
Yeah, sure.
Right, let's take one more question and make it a short one. Okay.
So, thank you for your presentation.
Thank you.
My question is, can you share with us more details or aspects about the recent cyber attack on a power plant, on Indian nuclear power plant?
No, I'm not.
So, can you share with us more technical details or information about the recent nuclear power plant cyber attack in India?
Yeah, I can explain after talk actually.
Okay, thank you.
That's some interesting stuff we have actually, but it's recording entire stuff, so I cannot explain as of now. But yes, I can explain it after talk.
All right.
Great.
Thank you very much for this awesome presentation and for the teaser of why you should look him up during the coffee break. But before the coffee break, let's give him a round of applause.